This is Unit 3, Lesson 1 on the coordinate plane. In this lesson, your objectives are that you can define key features of the coordinate plane and plot an ordered pair. The inventor of the coordinate plane was René Descartes, a French philosopher. He founded analytical geometry. He was considered a genius, and in fact the coordinate plane is often called the Cartesian plane after him. Descartes' coordinate plane allows us to reference points in space with a set of numbers. To find a point in a two-dimensional space, Descartes took an area and divided it up into two halves with a vertical and horizontal lines, and to make what are called four quadrants. The vertical or the horizontal line, let me see if I draw this for you. The horizontal line here separates the plane in an upper and lower half. Its values that it goes from the origin, or the center right here, to the right are all positive numbers, and to the left are negative numbers. This line right here that divides the plane is called the x-axis. The vertical line that separates the plane to the left and right hand side, whose values go positive as you go up and negative as you go down, is called the y-axis. There we go. Y-axis. If you ever forget which is the x-axis and which is the y-axis, think of this. You ever seen a railroad crossing sign? You can remember then the x and y axis with the little saying or rhyme, railroads lie on the ground, but yo-yos go up and down. So the x-axis is the horizontal line, and the y-axis is the vertical line. The point where they intersect in the center is called the origin. Right here. It's called the origin. The spot in the center has or any point on this plane can be described with two numbers. The first number is its x-coordinate, and the second number is its y-coordinate from the origin. So the origin, though, is the only one that has the coordinate of 0, 0. These coordinates are called ordered pairs. So once Descartes had separated the plane with an x and y axis, he creates four quadrants. Starting with the upper right-hand side, this is quadrant 1. All the points in this quadrant have positive x values and positive y values. Let me see here. So they'll have positive x values and positive y values. In quadrant 2, still in the upper half of the plane, because you're going up the x value, or because you're going to the left of the origin, the x values will all be negative, but the y values are still positive. In quadrant 3, the lower left-hand side, all values, both x and y, are both negative values. In the fourth quadrant, the bottom right, the x values are all positive, but the y values are all negative. So here's your vocabulary. Coordinate plane is formed when the horizontal line, or x-axis, and a vertical line, y-axis, intersect, forming four quadrants. The x-axis is the horizontal number line on the coordinate plane. If you think about a globe, the x-axis would be like the equator, or the line of latitude. The y-axis, or the vertical, is the vertical number line on the coordinate plane. If you think about a globe, a y-axis would be the prime meridian, or the line of longitude. An ordered pair is a pair of numbers used to locate a point on the coordinate plane. It's written in the form with parentheses x, y, where x is the x-coordinate and y is the y-coordinate. The x-coordinate tells you where to go first, and the y-coordinate tells you where to go second. To finish plotting your point, how can you remember this? If you use my example of railroads lay on the ground and yo-yos go up and down, you can remember this. One way is that you got to cross the railroad tracks before you play with your yo-yo, so x before y. Another way that's pretty easy to remember is that x comes before y in the alphabet. The origin is the point where the x and y axis intersect, and its ordered pair is 0, 0. So let's practice this and make sure you understand. It says label the x-axis. Well, the x-axis is the line that goes horizontal. The y-axis, I don't know what just happened there. X-axis is the horizontal line. The y-axis is the vertical line. It says place a point on the origin and label the ordered pair. The origin is where the x and y axis intersect. Its ordered pair is 0, 0. And if we label the quadrants, we start in the upper right-hand quadrant, and you work counterclockwise around. Quadrant 2, Quadrant 3, Quadrant 4. These are Roman numerals. 1, 2, and 3, you can see pretty easy. They just put a little lines and then a hat on the top and the bottom. If you're not familiar with Roman numerals, the V is the Roman numeral for 5, and when there's a line in front of it, it's like taking 5 minus 1 equals 4. So that's the Roman numeral 4. 1, 2, 3, 4. In the chorded plane to the right, at what ordered pair is this point located? Remember that an ordered pair is first your x value and then your y value. So what you'll do is you'll start at the origin and count over on your x coordinate. How far over is that? Well, since the point falls directly between 4 and 6, then the obvious number would be 5. 5 is between 4 and 6, so the x coordinate is 5. Then you'll count up. The point lies on the 6. So 5, 6 is its ordered pair. Remember, in the alphabet, x comes before y or z or whatever, so your ordered pair should always be listed as x, y. So in question number 2, we had to write the ordered pair. In this focus question, we are going to plot these points. Remember that you will always count to the right or left first, and then up and down. So the first problem, I'll go ahead and circle it in red, and we'll plot it in red. Remember, it's always x before y. Because the 4 is positive, we'll start at our origin and count to the right over 4. And then because our 9 is also positive, then we'll go up 9. Your point is the final destination of, so this point is the 4, 9. Try the next one. I'll plot it in blue for you. Since our x coordinate is negative, we'll start at the origin and go back 5. Our y value is also negative, which means that you will go down 7. So our final destination is where you will plot your point at -5, -7. It's right there. -5, negative 7. I'll plot the next point in purple for you. Our x-coordinate is negative, that means you'll go back 2. And the y-coordinate is positive, that means you'll go up 6. So there's your coordinate, or your point, negative 2, 6. I'll plot the final one in green for you. Our x-coordinate is positive, so you go to the right 8, but the y-coordinate is negative, so you go down 8. So there's 8, negative 8. Remember, always count the x-axis first and then count on the y-axis. Think about Superman. He runs fast before he flies up or down. Now turn to page 4 in your packet, solve all the questions on this page, and when you're ready to check your answers, or push pause, and whenever you're ready to check your answers, push play again. The first problem in each section has already been done for you as an example. Okay, push pause, do the page, and then push play when you're ready to check. Alright, we're ready to check. Point I is located over 1, 2, 3, 4, 5 to the right, so its x-coordinate would be positive 5, and 1, 2, 3, 4, 5, 6, 7 down, so therefore negative 7 down. If you have negative 7, 5, then you forgot that you need to count from your origin on your x-axis first, and then up or down next. So if you've done that, then go ahead and push pause and double check all your other answers to make sure you counted in the right direction first. You're always starting from the origin. If you didn't know that this was the origin, they had a y up here and an x here to let you know that this is the x and y axis. Point G down here is back on the x-axis from the origin, so therefore it would have a negative x value. And if you count over, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 over. And it's going down, so your y coordinate is also negative. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have negative 9. Make sure you count the line down below next. It's kind of like playing a game with a little child that always like to, you don't count the line that you're directly on when you start. You count the next line over. C is located right here. There's my C value. Remember, you start at your origin, you count on your x-axis first, so 1, 2 over. Because I had to back up, it's a negative 2. And then count up 1, 2, 3, 4, 5, 6, 7, positive 7. Point J is located right here. It is directly on the y-axis, on the y-axis. So any point that falls on the y-axis has an x-coordinate of 0 because you're not going to the left or to the right. So the x-coordinate is 0, but we had to go down 1, 2, it looks like 3, so negative 3. Point N is located right there. So we had to go back on our x-axis, 1, 2, 3, 4, 5, 6, 7, 8. So it's at a negative 8. And down 1, 2, 3. So negative 3. And I must have miscounted on something here. And that might be on a... No, it is right. because if we look at point J and point N are both on the same y number, so that's the reason why their y should be the same. They're both -3. In section 2, they want you to name the point with the letter that it's located on. So in question number 8, the point is at -4, so that means we have to count back 4. 1, 2, 3, 4. See, 1, 2, 3, 4. And -5, so you have to go down 5. And I must have done it kind of over enough. 1, 2, 3, 4. So we went down 5, and so that leaves us at point B. Number 9, the coordinate is -7, +6, so we go back 7 and up 6. Back 7, up 6. So that leaves us at point L. Question 10 is -5, 0, so we just go back 5. But because our y coordinate is 0, we don't go up nor down, so that leaves us at point E. And question number 11 is at +1, +5, so we go +1 to the right and up 5. That leaves us at point M. Question number 12 says that +7, so we go to the right 7 and then up 2. So that leaves us at point K. Questions 13 and 14 always stump students, so if you didn't understand or didn't get it, it's okay. You're not the only one. Question 13, the coordinates that are opposites. To find opposite coordinates, these would be equal distance away from one of the axes. And if we look here, for example, you can clearly see that that N and D, I just realized I wasn't recording there for a second there. Question number 13 and 14 always stump students. By the way, I'm sorry if I'm repeating this. I don't know where it's left off. So the coordinates that are opposite each other would be equally distance apart from the axis. If you look at N and D, they're both the same distance away from the y-axis. So those would be opposites of one another. Same with H and A. They're both 3 away from the y-axis, so those two are opposites. I don't know if we have any vertical opposites. Just a second. Nope, I don't see any. To give an example of a vertical opposite, if we look at point N right here, if we had a point that was equally distance away from the x-axis, so that's 3 away, you would expect its opposite to be located right there, but there isn't one. So those are the only opposites, N and D and H and A. Question 14 asks for what coordinate is the y-coordinate 5 times the x-coordinate? Well, think of it like this. If x is x, then the y-coordinate would be 5 times the x. So which one of these points fits that scenario? This would be a lot of guessing and checking. So to give you an example of something that might work is if x is equal to 1, what do you expect y to be? Well, 5 times 1 is 5. So do we have a point at 1, 5? 1 and up 5? Looks like we do at point M. That was just a lucky guess. But normally you would have to plug and check all the coordinates that are on your graph. Section 3 wants you to write down the quadrants of each one of the points. Now keep in mind, if a point lies directly on an axis, it's not technically in a quadrant. You would say it's on the whatever axis it's on. And if it's on both axes, then that point would be called the origin. So let's take a look at these. Question number 16, the point 7, 2. So we would count to the right 7, 1, 2, 3, 4, 5, 6, 7, and up 2. So it's actually right over here by point K here. Which quadrant is that in? It's in quadrant 1. And honestly, we should be able to tell the quadrant without even looking at the graph, because if we notice that our x and our y value are both positive, then that means it would have to be in quadrant 1. Just a reminder, in quadrant 1, both your x and your y values are positive. In quadrant 2, your x values are negative, but your y values are still positive. In quadrant 3, both your x and your y values would be negative, and in quadrant 4, your x values would be positive, but your y values would be negative. So let's apply those rules to question 7, or 17. In 17, we have a negative x, but a positive y. So that would put us in negative x, positive y would be quadrant 2. Question 18, they ask about point J. Point J is right here. It's on an axis, and in fact it's on the y-axis, so you would write y-axis. It is not in a quadrant. Question 19, we have a positive x and a negative y. So positive x and a negative y value, that would be quadrant 4. In question 20, we have a negative x and a negative y, so that would be quadrant 3. This is the end of lesson 1. You can go on to lesson 2.